Hey, curious minds, welcome back to SkySci. Have you ever looked up and wondered, why is the sky blue? Why not green or purple? Why does the sky sometimes look white or orange at sunset? And what would the sky look like on another planet? In today's episode, we're taking a journey through sunlight, air molecules, and a little physics magic to answer one of nature's most beautiful questions. Let's dive in. Let's start with the sunlight itself. To our eyes, sunlight looks white. But white light is actually a blend of many colors, like the colors of a rainbow. These colors range from violet, blue, and green to yellow, orange, and red. Each color has a different wavelength. Think of wavelength as the length of the wave of light. Violet has very short waves, about 400 nanometers. Red has much longer waves, around 700 nanometers. The difference in wavelength is what gives each color its unique energy and behavior. Now let's bring in Earth's atmosphere. Our air is made of tiny particles, mostly nitrogen and oxygen molecules. When sunlight enters the atmosphere, it collides with these particles. This is where the magic happens. A process called Rayleigh scattering takes over. Named after British physicist Lord Rayleigh, who first explained it in the 1800s, Rayleigh scattering describes how smaller particles scatter shorter wavelengths more effectively than longer ones. That means violet and blue light scatter in all directions. Red, orange, and yellow mostly keep going straight. But here's the twist. Even though violet scatters more than blue, we don't see a violet sky. Why? There are two main reasons. First, our eyes are much more sensitive to blue light than violet. Second, the ozone layer absorbs a lot of the violet light before it even reaches our eyes. So, what we perceive most strongly is blue. That's what fills the daytime sky. But things change as the sun moves toward the horizon. At sunrise or sunset, sunlight enters the atmosphere at a much lower angle. That means it has to travel a longer path through the atmosphere. By the time the light reaches us, most of the blue and violet light has already scattered away. Only the longer wavelengths, like red, orange, and pink, survive the trip. That's why sunsets and sunrises are so fiery and colorful. And sometimes, depending on dust, smoke, or pollution in the air, sunsets can even look deep red or purple. But what about those hazy days? When the sky doesn't look blue at all, it looks pale or even completely white. That's caused by a different type of scattering, Mie scattering. While Rayleigh scattering works best with small molecules, Mie scattering happens when light hits larger particles, like water droplets, fog, smoke, or dust. In Mie scattering, all wavelengths get scattered almost equally. That blends the colors together, and we perceive the sky as white or light gray. That's why humid, foggy, or polluted days often give the sky a washed-out look. Now here's a fun twist. Not everyone sees the sky exactly the same way. Human eyes contain three types of color-sensitive cells, called cones, each sensitive to red, green, or blue light. The way these cones respond to scattered light shapes how we perceive color. Some animals, like birds and bees, can see ultraviolet light, so the sky may look totally different to them. And people with color blindness might perceive sky colors in different ways too. So in a way, the sky's color is not just about physics, it's also about biology. Now let's leave Earth for a moment. On other planets, the sky could be any color, depending on the atmosphere. On Mars, the sky is often a pale yellow or dusty orange, because the air is thin and filled with red dust. On Titan, one of Saturn's moons, the sky looks hazy orange due to thick layers of methane and hydrocarbons. If a planet had a dense atmosphere made of neon gas, its sky might glow bright red or pink. In short, if Earth had a different atmosphere, our sky might not be blue at all. Let's test your curiosity. If Earth had no atmosphere, what would the sky look like? If our eyes were more sensitive to violet light, would the sky look purple? What would happen if the sun was much cooler and emitted mostly red light? These questions show how small changes in atmosphere, in light, or in our eyes could change how we see the world. So now you know, the color of the sky is a beautiful dance between sunlight, molecules in the air, and your own eyes. Simple question, fascinating science. If you enjoyed this deep dive, don't forget to like, subscribe, and share it with a friend who's ever looked up and wondered why. See you in the next episode of SkySci.